Okay, what's up, guys? So I started learning about algorithms, and it's not like I haven't looked into it before, but I started getting to know it better. So when I was still in school, obviously they taught us all these things. They taught us linked lists and all binary search, quick sort, merge sort, and all those other good stuff. But we never really um, practiced it, so to say. So after I started looking into these things, I saw that it's actually easy, but it's hard to understand. So what I'm going to be doing in this video is explaining certain algorithms that I'm going to learn and going to make it easy for you guys to understand and code along or whatever. So the algorithm I'm going to be looking at today is binary search. So what is binary search? Binary search is a complex, is a advanced search algorithm that works follows the principles of divide and conquer. What binary search does is that you give it a list. It takes the list in, it finds the middle of that list. If that middle is what you are looking for, it's going to return it. It's going to return its index back to you. If not, it's going to check if the value you are looking for is less than that item in the middle. If it is less than the item in the middle, it's going to take things that are in the array left side, and if it's not, it's going to take things that are at the right side. So as our code now, I'm going to explain it further. So let me start by putting the things we're going to use. So we have a link to search, a list to search, and we're going to find an element. The element to find is going to be 80. We have an array size, which is the size of the list to search minus 1, and then you are going to pass this argument into the binary search function, which will give us a result. Then we tell the user that the element you're looking for, that is the element we were trying to find, can be found at the setting index. So let's define our function. Binary search is going to have the following parameters. That is the array, the elements to find, we'll call it value, and then this thing called lower boundary, lower and upper boundary. Let me rename that. Boundary. So I'll explain what this is as we go. So first off, what we want to do is check if we are within the size of the array. I want to check if the upper boundary is greater than the lower boundary. So basically, what this lower and upper boundary are, they are representing the size of the array. For example, in this array we have is up to 7 or 8 or so. I'm not counting it. So the lower boundary is going to be here, while the upper boundary is going to be here. So that's it. So if indeed it's greater, that means we are still within least boundary. That means we are not out of boundary. We can still work with it basically. So if we are within the boundary, what we want to do is we want to get the middle element in the array, because that's what binary search is. You find the middle, you divide and conquer, find the middle. If it's what you're looking for, you take it. If it's not, check if it's less or greater than, and then all that stuff. So we'll call this middle, okay, middle boundary, no, middle position. And what this middle position is going to be our upper boundary plus our lower boundary modulo 2. So the reason why we're doing modulo 2, I'm sure you guys are already aware, because we want a whole number, not a decimal or floating. So now that we have the middle position, we want to use that middle position to check if that's what we're looking for. So if our array as middle position is equal to the value we're looking for, so if it's equal to the value we're looking for, we want to return with the position was looking at, let's say we're looking for, it is 56 now, 56, we're looking for 56. After we've taken the boundaries and done the modulo on it, it's going to put us around somewhere here, like here. This is the middle. So we want to check if this middle item here is what we're looking for. If it is, we're going to return it. If it's not, what we want to check for is if our array, so if the value we are looking for is less than the item in the middle position of our array. So after we've checked that 56 is not what we're looking for, we want to check whether the value we're looking for is either less than this 56 in the middle here or is greater. Say we're looking for 4. We are going to check whether 4 is less than 56, which it is. If it is, we are going to call the binary search tree on it again. So this is a recursive process. We're going to return this, and then we are going to pass in the following argument. So we'll pass in the array, the value we're looking for, and then the new one upper bound. So since it's less, we want to work with things that are less than that item that was in the middle. We no longer want to work with the item in the middle or items that are greater than what we're looking for. So if that is the case, our lower bound is still going to remain 0 because we're working with things that are less than what is in the middle, and obviously what we're looking for is less than what was in the middle. So lower bound is still going to remain 0 as we define here, and our upper boundary is going to become middle position minus 1. So the reason why we're using middle position minus 1 is because this is the middle position, and we want to work with everything that is less than that. So working with 34 all the way to 1. So if the value we're looking for is less than what's in the middle, we're going to return this binary function with the following parameters. Then else, if the value we're looking for is not less than what's in the middle, it's going to be greater than what's in the middle. So we no longer want to work with anything that is less than what's in the middle or is equal to what's in the middle. So call the binary function again, passing the array, the value, and also our new upper boundary and lower boundary. So our lower boundary is going to be going to start from here now. That is everything that is greater than what's in the middle. So it's going to be middle position, and upper boundary. So that this is going to give us this is going to search our list and then return to us the position of what it is looking for. So in a situation whereby we are no longer within the boundary, there is lower boundary is greater than the upper boundary, which should not be possible. So else we'll return index of bound. So it's gone past its boundaries. So if we run our program, it's going to give us the expected output. So okay, let me run that again so you see better output. So here we see that the element you're looking for, which is 4, can be found as index 1, which is correct. So if you look at it, this is index 0, this is index 1. Say we want to check for something else like 80. If you run it again, you see that the element you're looking for 80 can be found as index 7, and if you count it, you see that it is indeed as position 7. So yeah, that's all about binary search. If you like the video, please like the video, subscribe to the channel, and I'll see you in the next video I make. Peace.